Hey, how's it going, everybody? John Reagan with Boredbrains Consortium and Ulshe.ai. And I was actually so giddy last night. I was up till 5. I couldn't sleep. I was so excited. And some of the stuff I've finished off today is just like, oh, that's gonna be so awesome. And it is. It's actually really awesome. I can't wait to show you what I figured out. Before I begin, though, I want you to keep two things in mind, right? The first is there is millions of times more processing power and capability in your cell phone than the computer that guided us to the moon and back, right? Now, granted, times change and everything like that, but when you stop and think about that for a second, you're like, well, what are we getting out of that, right? Where is all this incredible processing power going, right? And if we really delve into that, I'm sure we know, right? It's going into big files that have all your information, to big things that are basically figuring out ways to package up your data and ship it out to somebody else so they can use it for whatever they want to use it for. And that's not what I stand for at all. I like privacy. I think that people are entitled to privacy. I think it's an American right. And, unless you have a warrant and you have some evidence, you should get to stepping. So to me, and even with all this, even with the registration and stuff that I'll have to do later for things, I'm working to maintain a level of anonymity for users that still allows us to be like, hey, like your number, or so to speak, came up in these things. We need to like discuss something with you. So there is still some tracking, but it's not like the Windows ID tracking stuff. It's actually very hands off, as anonymous as I can possibly get it, and more actually about tracking the AIs that you'll eventually have running. So the second thing that I want to cover before I really get into this is that when you look at the world, I mean, really look at it, like not like, oh, that's a pretty flower, but you start thinking about the flower and you think about what makes up the flower, and you think about what makes up the rock or the wood, or how do they know that they are what they are, right? What makes them, or yourself even, understand that you are that, right? Um, you start to see that everything actually is in numbers. It, don't go away. Stop. Hey, I swear we're not getting into math class. All right, don't change it. Everything is mathematical. All right, go watch Adventure Time. You'll figure it out. It's mathematical. But what I want to bring up to you right now is that when you begin to view the world in these numbers and these number sets and the compilation of them, you start to understand that you can do other things, because all you're doing in the end is really a manipulation of the numbers you have available to get a certain output. All right. And when you get down to it, that is really what an AI is. Okay. It contains a bunch of numbers that relate to different things, whatever that happens to be, things, whatever they are, ideas, concepts, a cat, dog, red, yellow, whatever it happens to be. And it calculates, right, how closely the things relate based off what you ask it. Okay. So it's all made of numbers. It's all even the architecture is a series of algorithms and componentable blocks that essentially manipulate the data that you've pushed or trained into this database system, right? Okay, so now we've covered that, we can do the fun stuff. So this, what you see right now, if you watched this before, you know that this is the Ulshe AI Professional Forge. This is built entirely in Rust. It uses as much bare metal for what I can do running it on a Ubuntu system or a Windows system I subvert some of the memory things around alloc, but I still have to deal with alloc in certain aspects of like the UI and everything like this. But this is a core library, which means you can use this versus, say, Python to build, train, and operate your AI models. Now, stop. I know a lot of you are like, oh, it's like llama.cpp, or it's like this thing from this company or this thing from this company. It is and it isn't. Okay. So, first of all, my intent was never to optimize this to run LLM models, open weight models. That was a little side vent I took when I started making it to do my own models, right? Because I have an operating system as well that goes with this and with the AI structures that helps to manage them a lot better and gives them a very lean environment. I'm going to show you that in a second. So this library I made to basically be able to run my models in the operating system, which is a bare metal Rust kernel, no standard libraries. It's all written directly to the hardware. So I needed a library, and of course, if I need a library, I want to use a UI. I have a terminal, I could do it that way, but I just didn't want to do it that way. And so, as you've seen before, this gives you the option for your models. This gives you the option for. Is that not floating up? There we go. This gives you the option for tiered, which is essentially filling up your VRAM if you have any, then defaulting to your RAM, and then defaulting to your SSD, your hard drive, essentially, to run the model. So it sometimes it's the fastest, sometimes it's not. All right, and I know a lot of us are obsessed with TPS, like the tokens per second. I get that because that's how quickly you're doing the calculations for use cases. But again, what I want you to understand is I'm not here optimizing this for LLMs, and I am. There's stuff I'm doing that is making it faster, but it's not. I'm not actually doing. That's why it's different from Llama and those you'll see here. So we have the waterfall. We have pure RAM, where you just run your heart stuff out of RAM. We have direct from the hard drive. This is similar to any of those. But again, instead of C, it's running in essentially as close to bare metal Rust as I can get it. And I have spec this out, importing it over to Polymorph, and it does look like I'm really good. There's only a couple little tweaks I have to do, and then it should slide right in. And then this is a core library for the operating system, and we'll get more into that in just a sec. So this is, of course, where you would run them, where you can run inference, you can launch models. That all works fine. The converter works fine. This benchmark pops up little squares that show you your TPS and what your time to first token was and how many joules. I have to do the joule calculations more accurately. They're just a rough estimate, so they're not really good. This is the forge here where you'll be able to build both Ulshe and legacy models. Here you can see if you switch to our Pico model, which is like a micro AI type daemon type model, specialist model. You can make little ones, as well as what will be full size models. The dojo is your reinforcement area. So this is where you load up models, you load up a additional like Q&A type curriculum, and you'll go through and basically just retrain the model in a certain number of training jolts, right, on specific stuff. This is the cognitive swarm, and I do have some of this already done on the back end, setting up the API gateway and the P2P bridge. Those are all established. I just have to link it into here. But that actually moves us to Network Brain, which is where you will actually see all of the available encryption approved nodes within your compute fabric. So if you have 6 computers on your network running this, and you do the handshake, the encryption handshake, the key handshake with it, they make a connection, and they can now act as a piece of your compute fabric, whether that's individually here, like in the swarm, right, where you might basically escalate your prompt and question through a few different AI models, getting larger as the complexity grows. Here you'll also be able to group them into a singular fabric for running full inference, training across the fabric, the node fabric, as well as reinforcement training and some other things I'm coming up with. It's kind of neat. This is going to be your system log area. As I've said before, you'll have tabs here. This will show all your runnings, and we'll have a list of saved system logs down below. You can click on review, check out, audit, what have you. Here's the manual. Again, this is where it'll just tell you how everything works, and it's going to take me a bit to get that done. But this is something I added, and this actually leads into the next thing. This is called arc blocks or architectural blocks. Now, because of how I've designed this with some extreme modularity and support across multiple different architecture types, including my own, right? Including the stuff that I've come up with. Once I get done with this, you'll basically be able to come in here, create a whole new AI architecture from scratch, right? You'll be able to click it, generate your Rust code, or save the overall topology and try to run it somewhere else or build it somewhere else in something else, different language or what have you. And then from there, you'll be able to bring it over here to the Forge, and you'll be able to run that your own architectures that you've designed and stuff. But this came to me in kind of dealing with creating a compliance with all of these other architectures and figuring out how to modularize all the various loos, that, as I call them, Swiglu, Glu, so Relu. Then you have Attafactor, Atom. I use a stochastic gradient descent at one point, SGD, which is kind of interesting. It's a light duty. It's not really recommended for anything like, commercial grade AI. But I mean, if you're sitting at home just dinking with it, sure, why not? So there's a lot of these different components, and a lot of stuff like this comes up. So as these are created, as they come up, you can see we have an RMS norm, we have the Hebbian plasticity and anxiety router, which is something I came up with. And so these things will be available to basically construct your own AI, right? Because I realized that all we're doing is taking and building with these building block components different structures to process the data or manipulate the numbers in a different way, right? And so as I thought about that, right, it occurred to me, I was like, well, I mean, if that's the case, then that means that all these components are basically just methods of manipulating numbers, and my PolyMorphOS is all mathematics. It doesn't, even the UI doesn't use bitmaps. It doesn't use polygons. It's not drawing or rendering an image off putting pieces together, and it's not frosted glass in my stuff. It's actually math that you're looking at. So I can actually tell you, when you look at the UI, there's nothing there. It's just numbers. And I'm going to show you what I mean. This is pretty cool. I want to see if I get the weight over. This is some cool stuff. I'm so excited when I will get ready to show this, because quite honestly, when I started getting this and when I got to work, I was like, oh my God, it totally works like this. It's like, so essentially, what I've done is the OS, the UI, the rendering system now works the same way these AI blocks work. It uses all the same stuff for rendering. I'm going to show you. This is fucking, sorry, pardon me, this is sick. Did I spell it wrong? Oh no, wrong one. I was thinking of the this thing. It's not the dashboard. I've been running these back and forth today, trying to figure out what I could do, checking the code, making sure it's gonna line up. Oh man, I'll tell you. Let me run this key move window over so you can see this. Now you see all that action, all that bounce? That's just pure math. That is pure math, right? Oh, you're not gonna be able to see the corner, the thing. That's okay. That's okay. Now maybe I'll just turn my camera off here so you can actually see. Hold on a sec. Oh, got a control G out of that. Yo, G. Got a control G. There we go. So now you can see the whole desktop, right? So now I'm gonna authorize via my USB stored key. So now we're in there, right? So now we're on the desktop. Some of you have seen this before, right? I'm going to play with it a little bit in ways I haven't done yet. So this will be kind of fun. So I've already ported over 2 apps from my original prototype of all this desktop stuff, right? All this PolyMorphOS stuff. And so the first one I'm going to show you is basically the interface for your host AI. And the host AI is the AI model, the .mdo file that you create using the Forge and drop in here. And then all of my registries, everything in the operating system is a tensor. So it immediately has access to everything. So, and don't worry, it is locked down. There's all kinds of security and ledgers and audits and checks for if it's trying to take an action that would destabilize the system, it gets shut down. But okay, so let me log in. I'm logged in, so let me hit run. This is the first WASM map. This is what we call Magic Mirror. And all that action you see right there, that's not like me taking an image and running an animation script on it and stretching it and bouncing it around. This is all pure math. This is just numbers being rendered in our 3D holographic space here. You're like, 3D holographic space? But what are you talking about, John? Oh, well, let me show you what it's like to have a universe on your desktop. So we just flew through the first desktop. We're now on the second desktop. So here on the second desktop, I don't have a lot of apps in here yet, but we'll launch one. And so there's the terminal. All that action you see, that is all just math. All of this window stuff you see, it is all just math. It doesn't exist as an image anywhere in the system. So this allows us to create a full 3D holographic, and I was trying to play with the 3D part because what happens is you have a 3D holographic desktop here, but we're giving you your familiar 2D with a little 3D action, right? So then from here, what we'll do, and I need to actually open another terminal to do this. There we go. Get over here. Like that, I'm gonna tune it down. I was all for fun. I was like, okay, that is too sick. I can't believe I can actually make it do that. So here's our first text editor, and it's not great, right? I just ported it over. There's so many UI components I have to work on right now. But this is the Code Forge, which is essentially a text editor, right? And a text editor and a code editor are basically the same thing in my mind. So we click on this one here in the title bar. Where are you? Oh, Blossom Apps being greedy. There we go. It's a little tricky. So I'm still working out some stuff on the interrupts and the timing and stuff like that. I've got it down pretty good from where it was. So we instantiated the code one, right? We have that on this screen. So just to kind of give you the effect, let me find the hitbox. So now you're on desktop 2, you can see that the desktop 3 stuff is just floating there in the background of space. And now we'll go to desktop 1, right? And so now we can see that as we pull this one forward, you have all those windows sitting back there. And just to kind of make it some fun stuff, let's just shoot right to 3. Actually, let's go to 4. Let's fly past all of them to a whole new desktop. A whole new world. There you go. So we're on desktop 4. And here on desktop 4, I'm going to go ahead and my hitboxes are a little wonky. I got to work on those too. I'm so tired though. It's so much work, even just getting the foundation ready. So this is the PolyMorphOS global settings. This is going to expand a lot, obviously. But here you can see we've got some initial starting of our UI drop downs. There we go. So, yeah, give that drop down. There we go. I got to do something a little better with that. So here you can select light mist, then you can come down here and click the apply settings that I have to work better on. Find that better. And where are we at? Okay, go cyberpunk. All right, cyberpunk. I can't remember what that was. I think it's purple. Yeah, cyberpunk, and then we got, which is kind of cool. I mean, we got cyberpunk universe. And then forest is one I like, so this one I might actually get forest. Run, forest! There we go. It's just green, right? But it made me think it would be kind of cool, just like the universe one up here for dark glass. I mean, sure, look, if you guys want me to call it something else, I'll call it something else. It's not even glass, it's a freaking universe on your desktop. But, and you can kind of see the pixels. We're at the edge, so we're kind of at the edge of the stars, you might say. And we'll just roll it back here to the front. And all this is being done right now with no GPU. It is being emulated in QEMU, and I do have my plan for moving this to a fully installable desktop system where all of the apps that I've made before pretty much will be available once installed, including the Ulshe AI Professional Forge to a functional degree. I mean, there's some stuff not everybody needs, right? Not everybody wants to make their own architectures. That's like for AI groups and stuff. But you will have the ability to install and load MDOs. You'll be able to, this is a widget. I'm still working out some stuff with the grab on that. Where is it? Come on, grab it. There we go. So, and the problem I have right now is because it still treats the widget like a window. And so, as you can see, it moves in and out like, oh, you want to be on that. But that's because this widget is actually your AI. And eventually what we'll have is all those little spots, all those little dots will be the information nodes that things are mapped to. And I know there's way more nodes. Don't even start with me. But the idea is that we'll work it more on a hubbing basis. So you'll have the node. It'll be a hub area of logic and consciousness. And then from there, if you want, you can zoom in, as you saw we can do here with the windows and the desktop and stuff, to those nodes, and we can actually extract what's in the node, what's being lit up, and everything like that. So, yeah, so that is the revised polymorph desktop system, and as you saw, the Ulshe AI Forge, which will be the core Rust AI functional library for our polymorph desktop here. And I am past 20 minutes, so I'm going to wrap this up. I was hoping to keep it under 10, but I'm too excited. It's not possible. So this has come along really, really well, and I am probably more than ecstatic right now. Even though I am insanely tired. Like just that I could reuse the components of all the work I was doing over the last like 3 weeks with different AI stuff to be able to bring something like this, right, to life is just like, oh, that is. And I'll tell you, actually, the rendering is so much easier. So, and it's all tensors. That's the other thing. Like all of this is based on tensor on the back end. So it is a highly portable structure for AI. So yeah, so this is pretty much an infinitely expandable desktop system. And I'm going to work more on that part. But as you can see, there is a lot of cool stuff here. We have the Connect eye. We have the webcam eye. I was just working on the sound and the microphone, which also are working off this same driver mathematics setup to process sound, right? Auditory, both in and out. Same with the visual. So yeah, that's just, I mean, I'm tired, but I'm so ecstatic. You can hear my voice, but I had to do this video. And more on this to come. Thanks for watching, and hopefully You think it's pretty cool? I think it's really cool. I think it's neat.